Okay, so let us solve all the questions of signal and system subject, and these questions were asked in electrical gate 2023 paper. So the very first question in front of your screen, 30 seconds, because very easy question. A continuous time system that is initially at rest is described by this equation, where x of t is the input voltage and y of t is the output voltage. The impulse response of the system is what? A, B, C or D. So you have to just find h of t. Two-step process. First step, take Laplace of this equation, rearrange and get h of s. Second step, inverse Laplace transform. Got it? H of t, the answer is, if you are saying Calcutta, yes, Calcutta is absolutely correct. Okay. Now, those students who are not able to solve, focus here. First step, taking the Laplace transform of this above equation. So we are getting Laplace of dy of t upon dt is s times y of s. The next term, Laplace of 3y of t is 3y of s, that is equal to Laplace of 2x of t is 2 times x of s. Now in the left hand side, y of s can be taken common, bracket is s plus 3, right hand side 2 times x of s. Now rearrange y of s by x of s, that is equal to 2 by s plus 3. Now this thing is nothing but h of s. Once you got your h of s, then take the inverse Laplace transform to get the answer. Taking this solution to the next slide so that we can take the inverse Laplace transform. Therefore, if we take inverse Laplace transform, the answer would be h of t is equal to 2 is constant, so it is outside. Laplace inverse of 1 upon s plus 3, this is shifting, which is done by exponential. So e to the power minus 3t into u of t. So this is the answer, which is Calcutta. So Calcutta is correct. Now we can move forward for the next question. Lot of questions were asked from signal and system subject, so it is becoming more and more important. Check it out. Next question based on the basics of signals. Check it out. NAT question. I will give you exactly 30 seconds because similar concept was asked in this branch only in the previous year, and I have solved it, so you know it very well. How to get the period of which signal? Of the signal x of n, which is described by this equation, and tell me what is the period rounded off to the nearest integer. NAT question, no negative marking. Sir, we have 3 function, this is DC component, so it won't affect our period. Next is this, where omega 1 is 15 pi by 8. Next term, omega 2 is pi by 3. Use the HCF concept, rearrange, get your answer. Okay, I should end the timer. It's not that tough. Check it out. The right answer is 48. Why? The very first step is getting the omega 1 from here and omega 2 from here. So omega 1 is equal to 15 pi by 8. Omega 2 is equal to pi by 3. Now, second step is if you need the fundamental frequency of x of n, we'll say it as, let us say, omega, which is equal to HCF of highest common factor between omega 1 comma omega 2, which is nothing but HCF of the fraction 15 pi by 8 comma pi by 3. How to get the HCF of a fraction? Sir, HCF of a fraction is HCF of numerator divided by LCM of the denominator. So this is now HCF of the numerator, which is 15 pi comma pi divided by LCM of denominator 8 comma 3. So what is common between 15 pi and pi? Sir, it's pi only common, highest common is pi. What about the LCM of 8 comma 3? Sir, 8 comma 3, it's just multiplication, 8 into 3, that is equal to 24. So this is your omega, but apparently they were asking you the fundamental time period, not the fundamental frequency. So the final step is rearrangement. Since we know omega is equal to 2 pi by t, so if we rearrange, t is equal to 2 pi by omega, and here we can say that since t should not be written, they are treating t as capital N. So as per the notation, as per their notation, if they are saying capital N, okay, so 2 pi by omega was how much? Sir, from the previous you have told it is pi by 24. Okay, substitute pi by 24. So it is now 2 into 24, which is equal to 48. So 48 is absolutely correct, and we are done and dusted. So now we can move forward for the next question. So the next question in front of your screen, check it out. Third question. This seems to be tough, but frankly speaking, very easy question, can be solved in 30 seconds. Why? Because the question is the z transform of a discrete signal x of n is x of z is given as 4z upon z minus 1 by 5 into z minus 2 by 3 into z minus 3 with ROC is R. Now you have to find a statement which is true from option A, B, C or D. So this is MCQ, only one statement is true. Tell me what is the statement. DTFT of x of n converges if R, which is nothing but region of convergence, is mod z greater than 3, or it converges when the region of convergence is between this range, or it converges when your signal x of n is a left-sided sequence, or it converges when your signal is a right-sided sequence. So what is the simple concept? Sir, DTFT converges when the region of convergence includes the unit circle. We have seen a lot of questions based on this concept. So which is that region which includes the unit circle? Check it out. In general speaking, we have 1, 2, 3, 3 poles. So 3 poles, 3 circles will come. You have to draw that first. If it was engineering paper, semester exam paper, we have to draw all these things. But in the GATE exam, you can solve this question little bit faster. Being a teacher, I have to give you the complete explanation. It's my duty. So suppose this is a Z plane. Okay. This is a Z plane. And then we have 3 poles. Let me go back and show you where are the 3 poles. So from here, we can see the poles are at Z minus 1 by 5, that is equal to 0. So Z is equal to 1 by 5, which is 0.2. Next, Z minus 2 by 3 equated to 0. So Z is equal to 2 by 3. What's next? Z minus 3, that is equal to 0. So Z is equal to 3. We have 3 poles. If you have 3 poles, make a cross. 1 by 5, 2 by 3. Suppose this is 3. Okay. 1 by 5, 2 by 3, and this is 3. Unit circle comes between this. Okay. Between this, unit circle will come. Nevertheless, if I make a circle from here, then my next circle from here, then the next circle from here, okay. So where is the unit circle? Sir, the unit circle is somewhere here, dotted I'm making, so that you get the idea. Our region of convergence, if it includes the unit circle, then our DTFT converges. So this is the unit circle. Now check it out. Option A, they are saying that the region is mod z is greater than 3. Mod z greater than 3 means the outside region. If you choose the outside region, this region do not include the unit circle. Check it out. Unit circle is here inside, and your option A is saying region outside. So outside, it is not including the unit circle. Hence, we are saying that option A is wrong. It won't converge. Okay, DTFT of x of n does not converge in this range. Now, what's next? Discrete time Fourier transform of x of n converges if mod z is greater than 2 by 3 but less than 3. Okay, mod z greater than 2 by 3 less than 3 is this range. This is your region. In this region, we can clearly see that our unit circle is included. So this region is the region of convergence. Your DTFT will converge, and hence option B is absolutely correct. Sir, why Kolkata and Delhi is wrong? Please also tell us that. Why Kolkata, Delhi is wrong? It is wrong because when you say that left-sided signal, okay, left-sided sequence, take this pole and take the left-sided version. Okay, so mod z less than 1 by 5. If I take that mod z less than 5, will it include the unit circle? Mod z less than 1 by pi. Sir, it is not including the unit circle. Therefore, this region is not a region of convergence. And what about that right-sided sequence, Sirji? Right-sided sequence, again we have a case in the right-sided sequence, which means the greater, right? Greater. So if that is the case, again you can choose this mod z greater than 3. Mod z greater than 3 is that region where unit circle is not included, hence there is no region of convergence. We can comment that option Kolkata and Delhi are the wrong option because they are not including the unit circle. These regions are not covering the unit circle. Only Bombay was covering the unit circle, and hence we are saying that DTFT converges if ROC contains unit circle. Okay, so now this was our third question. Let us move forward for the fourth question. Now this is one of the good question which was asked in the electrical paper. Check it out. The Fourier transform x of omega of the signal x of t is given by this. X of omega is equal to 1 when mod omega is less than omega naught, otherwise the function is 0. Which one of the following statement is true? Option A, x of t tends to be an impulse as omega naught tends to infinity. Option B, x of 0 decreases as omega naught increases. Option C, at t is equal to pi by 2 omega naught, x of t is equal to minus 1 by pi. Option D, at t is equal to pi by 2 omega naught, x of t is equal to 1 by pi. So GATE 2023 electrical, tricky question. Why? Because frequency function is given. Find the respective time domain function, then only you can comment on the options. One way is to use the formula, other way is you know that this is the standard graph, rectangular function. So the time domain signal would be a sinc function, sampling function. So the time is up. Now it's my time to solve the question. Okay, now focus. If you got the answer as option A, then congratulations, option A is absolutely correct. But why? Let us see. The first thing is to get your time domain function. So x of omega, if I draw the function, it is a rectangular function with constant amplitude 1, and it is working from minus omega naught to omega naught, correct? So this is our x of omega graph. Now if you need the x of t graph, we know it very well, rectangular, then the time domain would be a sampling function. So our sampling function is equal to sine omega naught t, whatever is the value here, that only comes. If it was omega naught by 2, here it is omega naught by 2. We have learned that in the basics. So sine omega naught t divided by pi t. This is the first step. Now the second step is they were asking us the value of this function x of t at t is equal to pi by 2 omega naught. Copy this to the next slide and then substitute t is equal to pi by 2 omega naught. If I do that, then x of t is now sine of omega naught into, check it out, t is replaced as pi by 2 omega naught, the whole divided by pi into, again we have a t, so t is replaced by pi by 2 omega naught. So what I can see here is clearly omega naught getting cancelled and sine of pi by 2 is 1. So the numerator term is 1, and the denominator term we have here in the denominator pi into pi square, and this 2 omega naught goes to the numerator. So therefore the final answer is 2 omega naught divided by pi square, which means clearly that Kolkata and Delhi both are wrong because pi is not there in the denominator. Pi square should be there. Very simple observation, right? So this is gone, Kolkata and Delhi is gone, A or B is left. So here I will write from this option C and D is wrong. So now we can move forward and we can investigate. Now the investigation part is, check it out, I guess they were saying that x of 0 decreases as omega naught increases is one of the option. The other statement, x of t tends to be an impulse as omega naught tends to infinity. Now check it out, if you make this omega naught tending to infinity, which means you are increasing the width and you are stretching towards the infinity. Similarly here also you are stretching towards the infinity. If that happens, can I say this graph will behave as a DC signal, amplitude 1 always? And for that, if the response is amplitude 1 always, what is the respective time domain signal? So it is delta of t. So let me write it here. If you are manipulating your x of omega graph as point number 3, if you are increasing the width omega naught tends to infinity, the graph now looks like this is omega and this is x of omega graph. Now this is 1 throughout. Okay, so if that is the case, then x of t is equal to delta of t. Again the standard results which we know. If you do not know, you have to use the formula. Once you know this, that x of t is equal to delta of t, obviously the next point comes to your mind that they were saying that x of t tends to be an impulse, which is absolutely true. We have seen when you are increasing omega naught, which is nothing but the width, it behaves as a DC signal, which is amplitude 1. If you have a frequency response where the amplitude is 1 always, then this DC signal response is happening when you have a impulse function. So x of t is equal to delta of t. That is absolutely true. If that is true, we are done. Option A is correct. But the question is why Bombay is wrong. That is also interesting to know, that x of 0 decreases as omega naught increases. They are asking relationship of x of 0 and omega naught. See, x of t, we know it very well. If you know x of t very well, then x of 0 can be found. Check it out. This is our fourth point. Can you find x of 0? If I substitute t is 0, then x of 0 is equal to sine of omega t is replaced as 0 pi into, oh, so this is 0 by 0 form. If this is 0 by 0 form, we have to use the L'Hopital. Therefore, if we use the L'Hopital, what we get is differentiation of numerator. Let me write in this way: limit t tends to 0 sine of omega t divided by pi t. Now one way is to use the L'Hopital, other way is to say that when t tends to 0, sine of omega naught t is behaving as omega naught t, and then you can do the tt cancellation. Omega naught by pi would be the answer. Other way is to use the L'Hopital and you have to do the calculation. Anyhow, the answer is omega naught by pi. Both the methods I have told you. So you can see the relationship that x of 0 is directly proportional. You can see the equation. X of 0 is directly proportional to omega naught. If it is directly proportional to omega naught, so when x of 0 increases, omega naught should increase. But in the option, what they were saying? In the option Bombay, they were saying that x of 0 decreases when omega naught increases. Inverse relationship. That is not true. So Bombay is wrong, Calcutta is wrong, Delhi is wrong. Only option A is correct. So we can see here from this slide, Calcutta, Delhi was wrong. From this slide, option A is correct. Let me write it here. Hence, option A is correct. Okay. And from this slide, we know it very well that x of 0 is directly proportional to omega naught. So that was not there in the option Bombay. They were telling about the inverse relationship, which was incorrect. Hence Bombay is incorrect. Now let us move forward for the next question. Again, one of the interesting question, because every option you have to analyze. You can see this is kind of 4 question in one. Hence student says, sir, the paper is very difficult because we have to check every option, and that is like 4 questions in one. This is MSQ. Which of the following statements is or are true? Now this is little bit controversial also. Let us see whether you can solve this question or not. Option A: if an LTI system is causal, it is stable. Option B: a discrete time LTI system is causal if and only if its response to a step input u of n is 0 for n less than 0. Option C: if a discrete time LTI system has an impulse response h of n of finite duration, the system is stable. Option D: if the impulse response is like this, mod h of n is greater than 0 less than 1 for all n, then the LTI system is stable. What do you feel? You have to check each and every statement. MSQ questions, every option you have to analyze. You have to rethink whether you are not missing any of the point. If you miss any of the point, you will make blunder and you won't get any marks. Okay, take your time. I will give you 1 minute 30 seconds, and I guess that's enough because the question is not that tough. Last 15 seconds to go. Okay, last 5 seconds. 4, 3, 2, 1, done. So the answer is only one option correct. You know what is that option? That option is this. This option is only correct. And obviously, sir, why this option is only correct? Because first option is absolutely wrong. If an LTI system is causal, it should be stable. Who said that? Suppose you have a signal 𝑒⁻t u of t. Is it causal? Yes. But is it stable? No. Increasing function, unstable. Okay, so this is not stable. So you got the answer. LTI system was causal, but it was unstable. So saying this statement as LTI system is causal, it is stable, is wrong statement. Okay. Now, option Bombay. A discrete time LTI system is causal if and only if its response to a step input u of n is 0 for n is less than 0. Now this is very, very interesting. What they are saying is that LTI system is causal if and only if, then blah blah blah. First you have to analyze this statement. A discrete time LTI system is causal. When a discrete time LTI system becomes causal, sir, when it satisfies this criteria. What is the criteria? Let me write it here, that causal LTI system should follow this criteria. H of n is equal to 0 when n is less than 0. Now we understood this thing. LTI system is causal, but then they are saying if and only if its response to a step input is 0 for n is less than 0. Now can I say that the input they are giving is a step input, so the response we'll get is a step response. So let us analyze that step response, how it would look like. So as per the given statement, they are saying that the input is a step input which is u of n, and then the response, the output, which is y of n is equal to x of n convolved with h of n. Agreed? So here we are getting a step response. Step response generally in notation s of n we say it. Nevertheless, therefore here we'll say that y of n, just for the notation, if you want to write s of n, that's okay. I'm just writing y of n as the output. Output is input was u of n. Okay. Let me also highlight this, that our input notation we generally give as x of n, and that is equal to u of n. So if I do the substitution, u of n convolved with h of n, and obviously when u of n is 0 when n is less than 0, then the output is also 0 when n is less than 0 after doing the convolution also. Therefore we'll say that y of n is equal to 0 when n is less than 0. So if they are saying that a discrete time LTI system is causal if and only if its response to a step input u of n is 0 for n is less than 0, makes sense. This is absolutely correct. We have proven, okay, that input was u of n. We did the convolution, we got the output. So output is 0 when n is less than 0. Why? Because this value is 0, 0 converted with h of n, answer would be 0 only. Now, next is Calcutta and Delhi. Calcutta is little bit tricky. Mark it star. Why it is tricky? Because this is may or may not be true. If a discrete time LTI system has an impulse response h of n of a finite duration, this system is stable. See, the concept is it should be absolute summable, which means summation of h of n should be less than infinity. But what if the amplitude, this finite duration, has an amplitude which is infinity? Then if you add the signals, then the answer would be infinity. If the answer is infinity, then it is not stable. For stability, summation of h of n should be less than infinity. I am saying in this, if we got some amplitude which is infinity, so in the summation, the resultant would be infinity. So if we get infinity, it becomes unstable. Hence, that part about the amplitude is not mentioned in this statement. Hence, we cannot comment about 100% stability. Okay, if they are saying we have a finite amplitude, we have amplitude such that it's not getting converted to infinity after summation, then we would say with 100% confirmation, okay, then the system is stable. But here that was not given, hence we cannot say this statement can be absolutely correct. Okay, this is may or may not be true. And finally, Delhi, if the impulse response is this, then the system is stable. Now this is tricky because here mod of h of n, basically amplitude nature they are giving us, that amplitude nature of h of n is between 0 to 1. Okay, so if I try to do the summation, suppose h of n is 0.8, 0.8, 0.8, many terms like this sampled we have. Okay, so if I try to add them, 0.8 plus 0.8 plus 0.8 plus so on and so forth, sir, the answer would be infinity. Yes, if the answer is infinity, then how come this LTI system is stable? If the answer is infinity, it should be unstable. Okay, so sir, we got it. This statement is wrong, because when h of n is 0.8, which is in this range, we are getting, after doing the summation, answer as infinity, which makes it unstable. So saying it's stable is wrong. So what's right? Which statement is true? Only Bombay is true. Easy. We can move forward for the next question now. So the next question in front of your screen, check it out.